Hello everyone. In this video, I am going to discuss about the process of union operation of binomial heap. And I hope that all of you have learned the introduction of binomial heap as well as the binomial merge operation in my previous videos. Union operation is an important process of binomial heap which consists of four important cases. So first, we must remember these four cases. What are these cases? So first we will check the order of x and next x binomial trees. If both are not same, then our pointers will move in forward direction. In case of 2, if the order of x and next x are same and also the order of next to next x is also same, then again our pointers will move to the forward direction. In case of 3, if order of x and next x are same but order of next to next x is not same, in that case we will link the x and next x binomial trees into a single binomial tree. So now in case number 3 and 4, we have to decide whether x will become as a child of next x or next x will become as a child of x. So in case of 3, if x is having the lesser key, smaller key in comparison to the key of next x, then next x will become as a left child of the x. And if x is having the greater key in comparison to the key of the next x, then x will become as a left child of the next x. So in the next, we will see the graphical representation. So here you can see the graphical representation, what the meaning of all the four cases. So case 1, if A, B, C, D are the binomial trees in a binomial heap, in that case, if your pointer previous x is pointing to A and x and next x are pointing to B and C, then we check the degree of x and degree of next x are not same, and also the degree of next to next x are not same, then our pointers will move ahead in forward direction. So previous x will start to point B, x will start to point C, and next x will start to point D, and again this process will repeat it. Now in case number 2, if x is pointing to B and next x is pointing to C and both are having the same order, in that case again we will check the order of next to next x or sibling of next x. If it is also same, again our pointers will move in forward direction. So there are two cases, case number 1 and case number 2. In these two cases our pointers will move ahead. So what will be the cases when we will link, when we will merge the two same order binomial trees, that is 3 and 4, that is case number 3 and case number 4. So what will be the situation? Now very important situation. If the order of x and next x will be same but order of next to next x will not be same in both the cases, here you can see this is of order k, this is of order k, both are same x and next x, but order of this next to next x or sibling of next x is different, then we will merge these two binomial trees in binomial heap. Now decision is which one will become child. So greater key will become as a left child of the smaller key. So in this situation we are checking key of x is less than equal to key of next x. So here next x will become a left child of x. So here you can see This is C will become as a left child of B. In the second case, if key of X is greater than key of next X, then X will become as a left child of the next X. You can see here B will become as a left child of C. So I hope that you will remember these 4 cases for the union operation. Now, if you have seen the previous video, you find that the same example I have taken, and we will continue. We will try to learn this binomial union operation with the help of the same example that we got after the operation, after the step number 2, binomial heap merge. So we got this result after merging the 2 binomial heaps. Now can you say this is a binomial heap? No, at this time we can say this is the heap which we get as a result after merging 2 binomial heaps. At this time it is not the binomial heap because it is violating the property of binomial heap. The binomial heap will always consist of the unique order of binomial trees. Means same order binomial trees must not be there more than one. So we have completed up to step number 3 in previous video. Now I am going to start the step number 4 and 5. So you will check here head position is pointing to a node. It is not nil. So 4 and 5 will be skipped. After that we will reach to the 6. So we will assign the pointers, 3 pointers. The previous X will start to point the nil initially. After that, second one, the head pointer will be as a X. So head H will be as a X. And then sibling of X will become as a next X. Now we will go inside the while loop and we will see whether we should merge the binomial trees or not. So in this case, first we will check the next X not equal to nil. Yes, because next X is holding the address of this one. It is not nil. So we will go inside and we will check if order of X and order of next X is not equal to, while it is equal to, so this condition is false. Again there another condition in OR part, so we will go for that. Sibling of next X means next to next X not equal to nil. Yeah, it is not equal to nil. So again in AND part we are having, there are 2 conditions, first this one and then AND. Again we will check the degree of sibling of next X is equal to degree of X. No, it is also false. So what we will do, it means we can combine these X and next X. If the degree of this one and this one is same but degree of next one is not same, so you can combine these 2 similar degree binomial trees. So we will reach here. Now the question is you have to select which one will become as a child. So if you see case number 3, you can see here case number 3. So in this situation, what will happen when you will compare the key of X is less than equal to key of next X? Yes. So this 18 will become as a child of 12. And sibling of next X, this one will become as a sibling of X. So which one is X? This one is X. And next X will be linked as a child of X. So you can see as a result. So you will find out this one. This is next X that has become as a child of X. And this was the sibling of next X. Then it is as a sibling of X. So after this we will reach to the last statement 21. Here this was already X pointer and now this is sibling of X become as a next X. Again we will move to the while loop and again we will check is next X not equal to nil? Yes. So again we will go inside and we will check the degree of X and degree of next X not equal to, but both are equal to. So it is false. So we will again go for the OR part. We will check the sibling of next X, means this one. Sibling of next X not equal to nil. Yes, it is not nil. It is pointing to this one. and also the degree of this one is equal to the degree of this one. So what we can do, that we should move ahead. Okay, so in this situation your previous x will come here, which was pointing to nil, and x will move to the next, and the sibling of x will be next x. This will become as a next x. After this, we again come back to the while loop and again check here, next x not equal to nil. Yes, it is not equal to nil because it is pointing to this one. So again you will check the degree of x and degree of next x. Both are same. According to condition it must not be equal, but it is equal. So what we will do? Again we will check sibling of next x. So this is the sibling of next x. Not equal to nil. Yeah, it is not equal to nil because it is pointing to this one. So again you will check the degree of sibling of next x is equal to degree of x. No, false. So what we will do? It means the previous two similar order binomial trees can be merged, can be linked. So we will reach here. Again we have to check if key of x is less than equal to key of next x. No. So we will go in else if case. So here again we will check if previous x equal to nil. Is previous x equal to nil? No. So again there is a else condition here. So we will reach here. And what we will do? Just we will assign next x will become as a sibling of previous x. So we have merged the 7 and 25 will become a left child of the 337 that we have linked x and next x. Okay. So after that you can see this is a next x, this is a previous x, and this is your sibling. Again come back to the x, next x will become as a x and sibling of x will become as a next x. Again we come back to while loop. Again we will check next x not equal to nil. Yes. So again you will check the degree of x not equal to degree of next x. Degree of x and degree of next x is same. So again it is false. We will move here. The sibling not equal to nil while it is nil. So what happened? Again this condition is false. So we will go else part, and it means the degree of this one and this one is same and degree of this one is not same, and also this is the end. So again we will combine this one and this one. So again you have to check whether 3 will become as a child of 15 or 15 will become as a child of 3. So here you can see now you are comfortable to add this 15 as a left child of 3. So now this process you can do. Sibling of next x will become as a child of this one. So you can link. After that we will reach here. So this will become as a next x. This will remain as a x. And again you come back here. Next x not equal to nil. So here next x is nil because after 6 there is nothing, no element. So now we will stop the process and we have completed the binomial union operation with the help of the algorithm. So I hope that you understood it in better way with the help of the algorithm. And finally you will return h. So this heap pointer will be returned, and that will represent binomial heap. So now it is perfectly the binomial heap. Thank you. Keep learning.